In this unit, we're going to study trigonometry. In this lesson, we're going to look at the tangent ratio.
Okay, hi everybody. In this particular lesson, we're going to look at the tangent ratio. Now, what we've seen in two previous lessons here is we've looked at how the triangles, the sides of the triangles can be kind of paired up. In the first one, we looked at the sine ratio where the opposite and the hypotenuse were paired up. In the last lesson that we looked at how the adjacent side and the hypotenuse could get matched up. And so really what we've done here is of the three sides in a triangle, the opposite, adjacent, and hypotenuse, what we're doing is we're pairing them up in different ways. Well, there's one other way that we could pair them up, and that is by pairing up the sides that are opposite and adjacent to a given angle. Okay? In other words, in this particular case, we're going to simply ignore the hypotenuse. We're not interested. So we're going to do the same thing here. We're just going to demonstrate the way the pattern works for what we call the tangent ratio. So in these columns here, we're going to identify the angle, and then we're going to identify the lengths of the sides that are both opposite and adjacent here. So I've got a 36.9 degree angle. Okay, opposite that is going to be 3. Here's the hypotenuse. This is the blank side here, and the remaining side is the adjacent, must be 4. 12.5, the one opposite that is the 3.1. The hypotenuse, again, opposite the right angle, is going to be blank, so the adjacent side here is the 14. And then down here, angle 70.2. Opposite that is going to be 8.32. There's nothing on the hypotenuse, and so the remaining side here must be 3. So just like in the previous ones, I'm going to take a look at this ratio here, opposite over adjacent. Okay. Now, you might wonder at this point here, well, why is it opposite over adjacent? Sine. Why was sine opposite over hypotenuse? Why wasn't it hypotenuse over the opposite? And there are reasons for these choices here. And actually, there are other trig ratios here that we don't look at. We only really need what we call these three primary trig ratios. But there are others that take into account those other possibilities. I don't want you to worry about why isn't it another way? Don't worry about that. There are other ways to do these things here, but these are the ones that we focus on specifically to get people used to how these trig ratios work. So in this case, we are choosing to build the ratio that's opposite divided by the adjacent. So in this case, it'll be the opposite over the adjacent, the opposite over the adjacent, the opposite over the adjacent. And this is going to be what we call the tangent ratio. Now, first of all, just like we did before, we are going to get the decimal equivalents. Whoops. So 0.75. 3.1 divided by 14. 0.22. We'll go 1. And then 8.32 divided by 3. So 2.773. Now what we're going to do is we're going to use the tangent ratio on the calculator here, the tan feature, and this will be the tangent of 36.9 degrees equals the tangent of 12.5 degrees is equal to the tangent of 70.2 degrees is equal to. And just like we've seen before, you can probably guess where this is going to go. The tangent button is going to be the third one here. Here are the primary trig ratios, sine, cos, tan. So in this lesson, we're looking at tangent, 36.9, and I get 0.75. Well, this one, when I round it to the nearest thousandth, goes to 0.751. But you can see they're basically the same here. Tangent of 12.5, 0.22. In this case, when I round it, I get 0.222. I wanted to make sure that at some point that these weren't going to be exactly 100% equal. And that's because in most cases here, when you're building the ratios, if you know the ratios exactly, then you're rounding the angle. If you know the angle exactly, then you're probably rounding the sides at some point. That's just the way this works. So when we see this little difference off in the thousandths place, that's because either a length has been rounded or the angle has been rounded. So there's no reason to get concerned about that. Tangent of 70.2 is 2.77, and actually in this case it goes to 8. So again, by the time we get to the thousandth spot, we're a little bit off here. But what are you supposed to notice? Well, you're supposed to notice that these are basically the same things, that the calculator, when we use the tangent ratio, is giving you the ratio of the opposite side over the adjacent. And we're going to call that tangent as opposite over adjacent, or TOA, tangent opposite over adjacent. And again, you've seen these little things show up in the last couple of videos that we've done on these topics here. In a little bit, we're going to put that all together, so it'll make sense what this last little bit has been in the previous little bit of work that we've done. Okay. Now, you should be familiar with what we're doing here if you've seen the last two lessons here. When you're finding unknown side lengths or angles using the tangent ratio, this is what we're setting up. So the way we do it is we're going to make sure we've labeled the triangles with respect to hypotenuse, opposite, and adjacent. So that's we identify that reference angle, that special angle, and then we write those in there so that we know what we're dealing with. If it's the tangent ratio we're going to use, then it's probably the opposite and adjacent that you either have a number for or a variable on. We replace the variables with the actual measures. Remember, theta will always be the angle. Opposite and adjacent will always be side lengths. And then to solve for the unknown, remember what the opposites are doing here. Okay, remember, and if we're setting up the ratios, we're going to do cross multiplication. If we're looking for the angle here, you might be using the inverse tangent function to get the thing that you don't know. It's probably a little hard to make heads or tails of what's going on here, so let's take a look at some examples and illustrate, or I should say demonstrate what's happening. Okay, so let's take a look at some examples here. So find the unknown in the triangles below, round all side lengths to the nearest tenth and all angles to the nearest whole. Okay, so here we go. So here's our angle at 37. That's what allows us to do the labeling. The longest side in the right angle triangle is the hypotenuse. Don't have that. But this side over here is going to be our opposite, which means this one down here, this is our adjacent. So because of the two sides that we're given, we're going to put the opposite over the adjacent. So that'll be h, I'm just going to use the variable that they used right here, over 20. Don't know what that ratio is, but I know that the calculator knows what that is. Opposite over adjacent is the tangent of 37. So, press my tangent button, 37. I'm going to round that ratio to 4 decimal places, just like we've done in the previous questions here. So this will be 0.7536. And I'll write that over 1. Whoops. Sorry about that. And then we'll cross multiply. So h times 1 is just going to be h, and this will be 20 times 0.7536. So which means I'm going to multiply that ratio there by 20. And I get 15.1 meters. So that means up here, this length right here is going to be 15.1. Got it. For this question, here's the reference angle that's important to us. Again, the side opposite the right angle is not given, so the hypotenuse isn't there. That makes this the opposite side. And the W here is going to be the adjacent. So because I've got the adjacent and the opposite, I'm going to find the ratio that's opposite over adjacent. That is going to equal 5.3 over W. I don't know what that is, but I know that the calculator knows what that ratio is going to be as long as I know the angle. So then I pull this out. That'll be the tangent of 31. And that's going to be 0.6009 if I round that to the 4th decimal place there. And this will be 5.3 over W. Put that over 1. And now cross multiply. It's just that in this case right here, with the variable in the denominator, when I multiply up here, it's just going to be W multiplied by that 0.6009, which means to find the W, I got to do one more step here. I have to divide. So now it's going to be 5.3 divided by, whoops, sorry, you Not seeing that. 5.3 divided by the value that I just came up with. So that's that second answer, that answer button that's on your calculator. And I will get to the nearest tenth there, 8.8 inches. And then one more here in this section. And notice in this case it's the angle that's the unknown. But this is still, because our attention is being drawn to it, this is still the reference angle. I don't know the hypotenuse because there's no label given to the side opposite the right angle. This is our opposite. This is our adjacent. Because those are the two sides that I have information about, I'm going to make the opposite over adjacent ratio. That's going to be 5 over 8. And in this case, that is going to be the tangent of z, because that's the variable they use there. Now, in this case, I do know the ratio, but I don't know what the angle is. So the angle is going to be the inverse tangent of 5 over 8. And again, we've done this a few times before. It was just now we're doing it with the different ratio here. So to get that, it'll be second tangent. Gets me that inverse tangent function right there. 5 divided by 8, I just put the ratio in there, and I get that z is equal to 32 degrees. Okay, let's take a look at a couple more problems here. Here we go. Ranger Rick is scouting the area around his watchtower. He wants to put a sign for directions at a specific spot. From his watchtower, he knows that he can see the spot 20 degrees down from the horizontal. So he's looking down at 40 degrees. If his watchtower is 45 feet high, okay, so this is going to be 45 feet over here too. How far is the spot from the bottom of the tower to the nearest tenth? So we're assuming that straight down from the horizontal where he's at here, okay, that's going to be 45 feet. The question is, how far over is that? Well, because there's no mention of the hypotenuse. They've even drawn it like this. I instantly went to this triangle here, but it's the exact same situation going this way. And actually, in this case right here, if this is 40 degrees, bear in mind that because the horizontal and the horizontal here are going to be parallel to each other, this angle here would also be 40 degrees. Okay, so, or you could have said that this angle here is 50 degrees, because remember, these two angles are going to add up to 90. So, based on the information that you're given here, there's a couple of different ways you could have set up the triangles here. I just went by default using that angle right there that they gave me. So I'm going to stick with what I had here. We're not given the hypotenuse, or we're not asked about it. I know that this side over here is the opposite, and that leaves this side right here to be the adjacent. So because those are what I've got here, I'm going to set up the opposite over adjacent ratio. So 45 over x. And I know that in this case, that's going to be the tangent of 40 degrees. Okay? Now, tangent of 40 is going to be 0.8391. I'll put that over 1, just like I've done every other time here. We'll cross multiply. So 45 times 1 is 45. Then it'll be x times 0.8391. And then I got to divide. And 45 divided by that answer that I just came up with is going to get me 53.6. So 53.6, I believe meters is what we were using here. Sorry, feet is going to equal x. That's how far over it is. Now, one more question. The city of Edmonton decided we need another bridge to cross the North Saskatchewan River. Ms. Mills, the engineer, is asked to make some measurements before they start planning. She finds the starting point on one side of the river is 45 meters above the river. Okay. She also finds that the total distance from the starting point to the other side is 620 meters. So basically what we're saying here in this particular situation here is we know that this is going to be 45 meters. And then we know that all the way across here is going to be 620 meters. However, she's a terrible engineer, okay, and has planned for the bridge to look in the diagram below here. Pretending that this bridge would actually stand, what will the angle be between one of the cross braces and the bridge? So in other words, we're looking for this angle right here, between the cross base and the bridge here. So we know the height and we know the span here. We're going to assume that that's at least going to be 90 degrees. So we don't know anything about the hypotenuse, and I'm not asking you for the hypotenuse. So because this is the angle that we're interested in, this is going to be the opposite side, which makes this the adjacent. So I'm going to build the opposite over adjacent ratio. In this case, I know that that is going to be 45 over 620. So I know the complete ratio. What I don't know is the angle. But again, I can use the calculator to go backwards from that. So my theta, my unknown, will be the inverse tangent. Okay, you're always going to use that second feature. Basically, it doesn't even matter what ratio you end up using in a problem. If you're looking for the angle, you'll always press that second first, then the trig ratio. So I've got my inverse tangent of 45 divided by 620. And we get here that this is this really small, it's basically 4 degrees, okay, which is really, really quite small. Anyway, there you go. I hope this helps you get a sense of how these trig ratios work. Now what we're going to do, if you continue to work through the videos here, we're going to look at some questions where you're going to have to determine which trig ratio applies in the particular problem that you're working with.